Hey guys, welcome to the constant linear velocity force diagrams practice sheet. So we'll go ahead and get started with number 1, drawing the force diagram for the objects in their current state. So the first two, an object lies motionless, and an object slides at a constant speed without friction. Zero velocity, that motionless, is a constant velocity, and since the second one we don't have to deal with friction, we know that the force due to gravity on each of them will be the same as the normal force. There's no applied forces to it, and since there's no applied forces, we're just dealing with these two. I tried to draw the vector arrows as equal in magnitude, which again is the size of the arrow. Try to draw them as equal as possible. The third one here, the object is falling at a constant velocity. So we've got that force due to gravity pulling it down, but it's got a constant velocity, which means that there has to be another force at work here, because if there were just the one, it wouldn't be going at a constant velocity. That velocity would be changing. So we have an upward force to counteract that force due to gravity to allow it to fall at a constant velocity, and that is air resistance. I'll call that AR. An object is being pulled upward at a constant speed, so it already gives you a little F underneath that arrow, underneath that line, so that is going to be a tension force, and since it's at a constant speed, that tension force is of the same magnitude as the force due to gravity on the block. Now we get a challenge one, an object slowing down due to friction. So we've got force due to gravity and the normal force, right? Trying to get these vectors to have the same magnitude. They do. I'm trying to get my drawings to really represent that. But now it slows down due to friction. And friction, that force, is to the left. And we draw that force to the left because that's the direction that the force due to friction is acting on it. So now number 2, tractor pulling a log at a constant speed. Log weighs 3,750 newtons and the friction force due to the ground is 725 newtons. Find the tension in the cable. So first we'll start off, we'll draw the force diagram right on the log here. We've got force due to gravity. We've got normal force. Then we have friction. And we have tension. Now since it's moving at a constant speed, these forces are equal and opposite, they're balanced. And now when we go to find the tension in the cable, we know that the force of friction here is 725 newtons. And the force that is counteracting that to be balanced, to keep it moving at a constant speed, is the tension in the rope. It's 725 newtons. And that would be the tension in the rope. And just because it's good practice, the log weighs 3,750 newtons, so that would be that force due to gravity, and that also then equals the normal force. So move on to the number 3 here. Person pulling a 50 kilogram desk, we'll go ahead and 50 kilogram desk with an 85 newton force directed horizontally to the right. The desk slides at a constant speed. Again, that constant speed means that these forces are going to be balanced. The vectors will have the same magnitude. So we've got 85 newtons to the right, and that's the applied force. We'll call that FA, which means that we have a friction force acting in the other direction. Because he's pulling it if there were no friction, he would be pulling with that force and the velocity would be changing. It would not be constant like the question says. And then we have force due to gravity and the normal force. All of these vectors have equal and opposite magnitude, which means that they're balanced. So calculate all the forces here. A 50 kilogram desk. So right away we've got that force due to gravity. Goes the mass, in this case is 50 kilograms, times the gravitational field strength, which is 10 newtons per kilogram. So the force due to gravity is going to be 500 newtons, which is also the normal force. And then we have an applied force, F sub A, of 85 newtons. And that is what the friction force has to be to keep this moving at a constant speed. Now the last one. While on vacation, we've got a car which weighs 6,500 newtons pulling a trailer into the wind. The wind is pushing back with 225 newtons of force, and the trailer is also pulling back with 650 newtons. What object is pushing the car forward to maintain a constant speed? So again, this idea of that constant speed means that the forces must be equal and opposite. They must be balanced, which means that the vectors, the arrows, need to have the same magnitude. They need to have the same length. So right here on the car, we will go ahead and draw this. So we've got the car right here. Here we've got the trailer. I'm an artist, so those are very, very accurately drawn cars. So now when we're drawing the forces on here, we have the force due to gravity of the car, and then we've got the normal force. Now we have the trailer pulling back. We'll call that force trailer. We'll call that force trail. And also pushing back on the car, we've got the wind. So we'll go ahead and draw that here. We've got, I'll call it FW for F wind. So then it wants to know, what is pushing this car forward to keep a constant speed? Now this is a little bit tougher conceptually, but as these tires are rotating, normally we would say that friction is what's, acting against moving at a constant velocity, but in this case, the friction between the tires and the road, as these tires rotate, it's causing friction, but that friction is allowing this vehicle to move forward. So here we have a friction force is actually propelling and allowing this car to remain at a constant speed. So moving on to the calculations, we have the weight of the car, that F of G, force due to gravity. The weight of the car, 6,500 newtons, and that is also the normal force. So now we have two forces trying to keep this car from moving at a constant rate, and that's the wind and the trailer. And those two have to equal the friction force of the tires working against the ground. So we have 225 newtons for the wind, and then 650 newtons for the trailer. So that total is 875 newtons, which then has to equal the friction force that is keeping this object moving at a constant speed. And there is your constant linear velocity force diagrams practice.